Hello everyone, welcome back to the video lecture series on Basics of Electrical and Electronics Engineering. I am Sajitha. So this video series is again a continuation of a full wave rectifier. In the previous video we saw about the different types of full wave rectifiers. So one was the center tap rectifier and the other one was bridge rectifiers. So the primary difference between the center tap and the bridge rectifiers was that in the center tap there was only there were only two diodes which is present in the circuit, whereas in the bridge rectifier we saw that there were four diodes connected in the circuit. So the operation of the bridge rectifier in the positive cycle was discussed detailed in the previous lecture series. So now in this series we will move deeper into the negative half cycle and its function of a bridge rectifier. So here you can see that during the negative half of the cycle, the bridge rectifier conducts in such a manner that the two diodes which were conducting in the positive half cycle, that is diode D1 and D2, is now said to be in turn off condition, and the other two diodes, that is diode D3 and diode D4, is said to be in on condition. So when this condition appears, you can clearly note that during all the conditions, not only during this condition, during all the condition, it is very clearly noted that only the diodes and the current flowing through them is same. The direction of the current is not going to reverse, the direction is going to remain the same. So from when to when is the diode going to conduct? Diode D1 and D2 conducts for 0 to 180 degree, or in the other words it can say that it will conduct from 0 to T by 2 of the time period, if T is the total time period of one cycle. And then we can see that the other two diodes which are conducting in the negative half cycle is said to be conducted from T2 to T, that is from 180 degree to 360 degree. In both the cases the magnitude is said to remain the same. So now once determining all these, we have to find over one full cycle the input and the output voltage will appear as the same. So here Vm is nothing but the maximum voltage, whereas VDC is nothing but 2 into 0.318 of Vm, which is nothing but 0.636 of Vm. So this is what going to be contributed when we use the full wave bridge circuit. Coming to the frequency. The output frequency of the full wave rectifier is equal to double the input frequency. This means that when the input completes one cycle, then the rectified wave might have completed two cycles. So 2f is nothing but, f is nothing but 2 into Fn, which is when the input cycle is from 0 to 360 degree, the output shows that it has completed two cycles, that is one from 0 to 180 degree and the other is from 180 to 360 degree. Now as we have discussed too much about different types of rectifiers, can you suggest which rectifier is going to be higher in efficiency? Yes, it is definitely the bridge wave rectifier, which is going to prove or which is going to show a very high efficiency. So here, though we say that it is showing or it is going to give very high efficiency, so what is going to be the percentage of full wave bridge rectifier? Yes, the percentage of efficiency in a full wave bridge rectifier is going to be 81.2%, which is highest of all the rectifiers. Thank you.